Today's lecture is on JavaScript 3, which is the last part of the JavaScript series. And we're going to be focusing on things like scope, asynchronous JavaScript, functions, arrow functions, callbacks, promises, and like these things which are extremely integral to like making to actually coding so that you can actually like have a code which is optimized and maybe focuses on things like retrieving data and like we're gonna be and like so promises and callbacks play a role into that. Uh, so as far as the functions are concerned, there are two ways of defining functions. Yeah. So there are two ways of defining functions. One is the regular way where you use the function keyword and then have the name of the function with arguments in front of it, and then you do your thing with the function whatever you want, and then you return the value that you want. And then there's a function definition which is known as the arrow function. It is very similar to lambda function in Python, if you know about that, and it's used to make code simpler and more elegant. And like, later in the lecture you'll get to know that arrow functions are used for callbacks, and you should not use arrow functions for objects, right? And like it works in a very similar way. You have to you define the variable as the function name, and then you have the inputs, you have the arguments as like x comma y, as you can see, and then you use the equal to and the and the greater than sign, which makes it look like an arrow, right? And then after that you have the computation inside it, and like in our case, since we're just returning x plus y, you can also remove the curly braces, and you can remove the curly braces and just write x plus y and remove the return word as well. That works as well when defining an arrow function, but like the curly braces are required if you want to do like multiple computations. And then talking about scope, so there are basically two types of scopes. One is global scope and one is local scope. So when a variable is defined in the global scope, it can be accessed anywhere, even if it's like it can be accessed anywhere, whether inside a function or not. And then, for example, like at the starting of your whole like file, if you're defining a function, if you're defining a variable, that'll be in the global space, and it can be accessed inside another function that is defined later in the code. And like with local scope, it's the opposite. If you're defining a variable inside a function, it's only accessible within that function. And similarly, there's this thing in JavaScript known as block scope. So if you're defining something inside a curly braces, for example, like in an if statement or else statement, then that variable will only be accessible within that curly braces. Then there's something called the lexical scope, which is not defined here, but which is it's extremely intuitive. It's basically if you have nested functions or next or nested block scopes. So basically, the the variable defined in the inner curly braces won't be accessible by outer blocks or outer scopes. So the scope is nested in its own way, and then there's like maybe a bit different from languages like Python. There's like a difference. There are three different type of variables that you can define. So it's like var, let, and const. Var is like the var, like in terms of like how JavaScript was made. Var was the first one that was introduced, and it's like a very generic variable where you can update and redeclare it later as well. And if the variable is defined in the global scope, that can be accessed in the local scope in a later function or something like that. And but the problem with var was that it can be redeclared as well inside the function, inside the later function. So if you had defined a variable out in the global scope, and then you redeclare it in the local scope, you're essentially changing the value of the main variable, and you might like unless and until you're doing that knowingly, you might be losing out on information, and it may not be detected by the compiler, and it could like result in a big error, and maybe you can like lose out on information. So then we have the let variable type, which is block scoped, and similarly const is block scope as well. It can be updated, but it can't be redeclared, which protects you from the redeclaration problem that was there in the variable in the var. And with const, it can't be redeclared and can't be updated at all. And a caveat. So if you declare a letter, a var, for example, like var x or a let x, you can actually have the value in x later on. For example, x is equal to 5 or but the thing with const is, since it can't be updated and can't be redeclared, you have to initialize it at the point of its initialization, which is const x is equal to 5. That's something which is different from var and let with const. After that we have uh, this, which is basically uh, it's a keyword which has different meanings in different contexts in JavaScript, and which it's essential to know what it means in different contexts before we get into actual coding. So if it's inside a object, this refers to the uh, object. For example, like if there's a person object with age, name, etc., this dot age would refer to the age that was specified before. uh, but like different from this is like if we're not dealing with objects, then it refers to the window object, which is the global object of the whole project, for example, that you're working on. And this basically refers to the object window, and there are some functionalities associated with that which is not very prominent, and like you can read more about it like online, and you can get like if you're interested into that. After that, I think we can jump into asynchronous JavaScript, and Josh will take over.
Cool. All right. Before I move on to async JavaScript, are there any questions that people have on the topics that we reviewed before?
Yeah. So block scope is basically another type of scope, which is for example, if you're defining an if condition, and then you must be remembering that you have the curly braces. So anything defined inside those curly braces is a block, and any variable that is defined inside that can only be accessed within that curly braces, and that is basically what block scope is. You can understand it like by understanding that like a curly braces represent a block, and anything inside it can only be accessed within that block. Yes, if falls in that particular case, if is block scope.
All right, cool. Are there any other questions that people might have? All right, cool. I think that means that I can start on asynchronous JavaScript. So first off, what is asynchronous versus synchronous code in JavaScript? Synchronous code is something that we have seen previously with our JavaScript code. It basically is the concept that you write your code, and you expect your code to run one line at a time. And if there are any delays in the code, it will expect the code to wait for that previous line to finish running before running the next line. And so this already can present itself a problem that we can see in our code, and that it can introduce very many delays in our code that might not be very good for our functionality. And so this is where asynchronous code comes in. So it can run multiple lines concurrently, and it also will notify the program when code has finished with the result, so that if it starts another line after or before a previous line has finished running, the program will still know what the value of the previous line is, even though you have essentially skipped over it with asynchronous code. And this is useful for fetching data from like remote server, because you don't really know how long it's going to take to fetch data from a service that is not your own. So from a remote server, it might take like a couple hundred milliseconds, or if there's something wrong, it might even take a lot longer than that. And you don't want that kind of runtime to slow down your own code. And so the depiction or the picture that we have shown sort of shows the differences between synchronous and asynchronous code. So for synchronous, you can think about it as a single thread of control, or for a single thread of control, you can think about it as a line, and the program basically runs on this line. And if there are any delays, which are shown in the blue, your program will have to wait through these delays before starting the next thread or next part of the thread. And similarly for two threads to control, it's going to have to wait for the entirety of the process for it to start the rest of the code. However, for asynchronous code, you can see that there are two sort of function calls or two processes that are run simultaneously at the same time. And regardless of when they are finished, you can keep running as many as you want. And that should help with the performance of your code. And so moving on to how we implement this kind of asynchronous code in our own projects. So what are callback functions? These are used to make a callback to asynchronous code when we're finished. And this is what I mentioned previously. We want to be able to have our code sort of look at the value of some previous line that was ran, but we may have skipped over it because of the asynchronous code style. And so we need to call back to that line or several lines of code when the asynchronous code has finished. And so callback functions are used to do that. And they are provided as additional arguments for asynchronous functions. And additionally, nested callbacks contain asynchronous code. And so what does that really mean? Well, I'll provide a couple examples of callback functions. So here we have a function called setTimeout. This is built into JavaScript. Essentially, it takes a callback function and a delay amount of time in milliseconds. And so after the delay has happened, it will call this callback function. And so this is a pretty simple example of a callback function. Once this delay of 500 milliseconds has been run in your code, it will call this console.log on tick, and it will simply just log out tick to the console. And here's a little bit of a more complex example. So, and this makes use of chaining callbacks. So we have a function called fetch data, which we define to take in some username and a callback function. And so within the function, we see that we try to do some fetching of data. This probably will be from some remote server or some database that we don't know about. And we fetch some information based on the username of this person, and we call the callback function on the result. And so to use this function to see it in action, we call the fetch data function on some username, and we pass in it a callback function. So this callback function will take its response, which if you can match back here will be the results from fetching the username. And then it will pass it into another function called process data, which in itself takes another callback function. Once it has processed the data from the response, it will send it over to load data. And load data, you can imagine, probably just loads data on your website, in your project, something like that. And so this is the end of the chain of these functions. And so you can think about it as, first, we try to fetch the data, we wait for some time, then the response of this data is sent into process data, where we do some pre-processing. Maybe we convert it to a JSON object or an object in JavaScript, or however else you want to process this data. And then finally, we take that process data and we send it into this last function, which is called load data. And then we do whatever we want with that data locally. However, there are other ways to implement asynchronous code in our projects. And one of them is called, or one method is called promises. So as you may have seen with the previous example, there are some callback disadvantages that you might quickly run into. And that's that callbacks can get messy really quick. Even with the simple example that I showed before, you may have been a little bit confused, or may have been a little confusing to read through the callback, the nested callback structure. And that's because even something as simple as fetching data, processing it, and loading it has two callbacks that are nested 3 times. And so lots of nested functions can get hard to read on the eyes, and it makes it really hard to debug, because when something goes wrong, you don't really know where exactly in this stack of nested functions that the error originated from, without doing maybe like a lot of console.log statements to try and figure out where exactly this error came from. But so there has been a new invention called promises that make life a lot easier for you when you're working with asynchronous code. And this will help you produce actual human readable code. And so what exactly are promises? As I said before, they are another way to write asynchronous code. And they basically just promise that your code will be resolved later. So essentially the same thing as callbacks. If you have some asynchronous line of code that you want to get back to later, these promises promise that they will notify your program when this asynchronous line of code has been resolved. And so more specifically, promises are objects that may produce a single value sometime in the future. And these values might be a resolved value. Perhaps you're fetching data from like a remote server. The resolved value will be the data that you want to fetch. Either that, or it will have a reason why it has not been resolved. And that's usually when some error has happened along the way. Maybe the database is down, so you can't actually fetch the data that you want to, or maybe something internal has happened, like maybe you're not connected to the Wi-Fi, so you can't actually send HTTP requests. In any case, the promise will also be able to handle those cases and send your code locally that there has been an error. So next, there are 3 possible states for promises: fulfilled, rejected, or pending. As you may expect, due to the nature of promises, they can take an indeterminate amount of time to resolve themselves. So pending is just that time, that state when they are still trying to execute that asynchronous line of code. But once they have been resolved, they will be fulfilled. Either that, or if there has been an error, it will be rejected. And so those are the 3 states. And lastly, it is possible to chain your promises. And this is the basis of what allows your code to be a lot more human readable. There's no more nested functions. Instead, you can use chaining, which I will show an example of, to establish an order of which these promises will be fulfilled. And you can use chaining with .then or .catch keywords. So here's an example of creating a new promise in JavaScript. We just we define a helper function called wait, which is just an arrow function. It takes in some time and returns a new promise that basically waits a certain amount of time before resolving itself. And to read this promise constructor, we can see that it has some kind of function that is inside the constructor. This is called the executor function. And so once the promise is made, JavaScript knows to execute this function. In this case, it takes in a parameter called resolve, and it will set timeout and call it on resolve and the time that you have assigned it. Resolve is a callback function, and set timeout can take callback functions to, if you recall from before, it will just execute this resolve function after a certain amount of time has passed. So resolve will be a callback function, and you can think about it sort of as like a return statement. The promise will call resolve on whatever it wants to return when it has been fulfilled. And that's how you get the value of the promise once it has finished executing. All right, and so moving on, we can see the next line of code will construct a new promise with a wait time of 3,000 milliseconds or 3 seconds. This is a promise, which is returned by the wait function. And then we can see some chaining happen. So this promise needs to have, we want to have something happen after this promise has been fulfilled. So we use .then to sort of signify after it has been fulfilled, then we do these two functions. And in this case, the first function is a callback function that will be called once it has been fulfilled. And the second one is the callback function that will be executed if there has been an error in your promise. And so we can sort of see that this code, when run, will just console.log hello because there realistically should not be any errors with set timeout. An additional sort of way that you can write this code, you can, instead of passing in two callback functions and two .then, you can have a .catch statement at the very end, which will catch any errors that have happened in your code and sort of execute the callback function inside there. So that makes it even more readable for you, and will basically just make it a lot easier on the programmer to be able to understand what is happening with your code. So are there any questions about promises or callbacks so far? All right, it seems like there are none. So I'll move on to the last part of this lecture, which is fetch. And so what is fetch? The fetch API allows for calling data from another API. So this is the keyword in JavaScript that we use in our code so that we can actually send a request to another URL to get data. And so it takes a URL, and that will be the endpoint or where you want to fetch the data to or from, and sends an HTTP request to it. Once that has been done, it will fetch all related data from the API that is sent back from this URL. And lastly, this makes use of promises in order to run with asynchronous code. And so knowing this really helps with our programs to be able to fetch code from sort of a remote URL. And all right, so in order to provide a good example of how asynchronous code is used inside a project, we have a demo prepared for you guys about how to use the NASA API for the astronomy picture of the day. And so essentially, we want to be able to query this API from NASA to be able to take all the information from this web page and use it locally in our own project. And for those of you who want to follow along, it is possible to access this API from this website. And so NASA protects their APIs kind of with API keys. So you have to generate your own API key if you want to have access to their APIs, so that you are not able to like spam their API and jam their servers with requests. But I'll send it in the chat so people who want to follow along can generate their own API keys. And this will be necessary. You'll need to pass this information along in your requests so that this NASA API will know that you are sort of registered with them and that you can actually access the information that is at the API endpoint. All right, so first, what do we want to do? Let's create an index.html file for ourselves. And this will be sort of the bulk of our website. And to keep things simple, I'll just try to copy the layout of this website pretty closely so that no specific styling will be hindering the fetch part of this lecture. But anyways, we'll begin with some tags. Let's call our H1 tag astronomy picture of the day. Next, there's some image we wish to input, and some text and some and an H2 tag that we wish to also implement. And so I'll also real quick do a little bit of styling. Feel free to touch up on the styles. This is not like perfected or anything, but this just helps make it a little bit cleaner to look at so that you will not be able to, or we will be able to focus more on pulling the data from the API. All right, so sort of see what this looks like. Okay, so far there's just an H1 tag, starting picture of the day. Nothing too special. Okay, so what do we exactly want to do? We want to get this image from the API as well as information about this image. And so if we take a look at the API documentation, It will be under the Browse APIs section of the website. And what we're interested in is the astronomy picture of the day, which is the very first one. And so we see that the HTTP request URL is this. And so this is what we want to fetch from. So how do we do that? We copied this URL and we want to be able to use that in our JavaScript file. So let's create a JavaScript file. You can call it anything you want. I'll just call it lecture6.js, but yeah, doesn't really matter what you call it as long as you link it correctly in your HTML file. So now we've linked the JavaScript file to the HTML file, so this will run alongside this HTML. So that's cool. What do we want to do? We want to fetch from this URL, and this is where the key comes into play. They're already providing us sort of a parameter that we can pass into this API called the API key. You will post or you'll paste your API key here. Mine I have already generated will be this. All right, cool. So this is just a basic fetch statement. And as I mentioned before, what does fetch do? It returns a promise. So we have to do something with this promise. Otherwise, we have no idea what exactly the value is returned. It's just going to execute this fetch statement and it's going to do nothing. So what happens after we try to fetch this information? Here's our first callback function that we want to use. Whatever response we get back from the fetch, we'll do a little bit of pre-processing. So we will turn it into a JSON object, basically just an object in JavaScript. And then after that, well, I suppose we just care about returning this. And then next, there's some data. So let's sort of see what exactly this API is returning. If we go back to our index.html on our website and we inspect the console, we can see that the fetch has actually done something for us. And so it has fetched some data from NASA about what we saw on this website over here. And let's see if we can try to match up the data we see in our fetch request with what we see on their website. And so there's a couple of fields that we see here, like the date. Today's date is October 3rd. There's some exclamation field, which we can match up to this right here. And there's an HD URL. And so these basically just show what exactly we want to take from this response and put it on top of our own website. And so to do that, we want to be able to edit our own elements inside the HTML file, which we can do pretty simply if we just add some ID tags. So let's allow our HTML elements to be accessible by our JavaScript file. An easy way to do this is simply just do ID tags, and then inside the JavaScript file, to sort of access this, we will be able to create variables. Let's say photo element, document, get element by ID, and we pass in the ID. So this will be NASA APOD. The document is basically your website, and it will sort of look through the elements on this website, sort it by ID, and sort of get this element NASA APOD, which we have specified here as the image. And so that's all good. Now we want to have the HD URL be the source of this image. So how do we do this? Pretty simply, we can just grab the HTML element that we have defined as a variable called photo element, and then we can just set attribute. Which attribute do we want to set? The source, and what do we want to set it to? The HD URL from data. So and if we look, if we look back to our website, we see that we have actually fetched this this URL from the API, and we have successfully placed it into our own website. I will also make this image a little bit smaller so that it's easier to see. Okay. Next, we do something similar. We want to be able to access this explanation field from this data and put it on top of our website. And to be able to do that, once again, let's put some ID to our paragraph tag. Let's just call it explanation. And create a new variable. And within our callback function, once we have the data, we can set the attribute, set the inner HTML to the explanation field from the data. All right, so let's see if that worked. Okay, and so we have successfully taken the explanation field from the data and fetched it back onto our own website. And I see there's a question in the chat that says, why can you use response in data without declaring? Very good question. It's because I'm sort of defining this callback function to take in something called response in data. So what happens with chaining with promises is that they will return some sort of value, right? And the only way to be able to access this value is by .then or .catch statements. And within these .then and .catch statements, we need to also provide a callback function. And the callback function basically takes in this response from the previous promise, and it can do something with it. And in this case, it can also return yet another thing. In this case, it'll be the response.json. And then the next then statement will take that return thing and implement it as its own input. So to answer your question, these are things that I've defined by myself. So I could call this anything, basically. And this will be bound to the output of the first fetch statement. And this will be the return value of this callback. And then finally, the next stop then statement will know to take this return value and input it into its next callback function. So, and just to demonstrate that this will work, yeah, everything still exists on our website, and we can see that the fetches still work. So, yeah, and so this is basically how you implement fetch inside your own projects and how you're able to use promise chaining in order to work with data returned by this fetch function. Are there any questions about this demo or anything in particular about this lecture? And I see that someone asked, what if the arrow function takes 2 or more variables? Yeah, I mean, it can. It's basically just how many inputs do you want to define for this? I could basically provide another input 2, but in this case, I don't really think that's necessary because we know that this fetch will only return one thing. So because even though I define something here, there'll be another input. It doesn't really change the behavior of the fetch. So we're essentially trying to chain based on the behavior of the previous promise, if that makes sense. But if you're asking in general for arrow functions, if you define another input, you're just going to have to provide more inputs when you call that function. So it's like any function that you might have seen in like 61A or Python. You can define functions with any amount of inputs, and as long as you provide those inputs into the function, you'll be able to call it. Does that answer your question? Okay, sounds good. All right, so this is just a basic example of how you use fetch inside your own websites to be able to get information from remote locations. And if you look on the NASA Open API website, you can see that there are very many different APIs that you could potentially look at. And they all will return different things. So feel free to explore a little bit and just see what exactly you can get from this, from these APIs. They will provide some sort of example query all the time. And this is what you will use in your fetch statement. Be very careful to replace the API key though with your own API key so that NASA will be able to know, or the API will be able to know who's being able to access this. Yeah. So are there any questions about the JavaScript or what I've used to, I guess, grab the elements from the HTML page? Okay, it seems like there aren't any questions. So that's it for the demo, I guess. So some final announcements. Homework 3, JavaScript, is due October 10th, and homework 4, React 1, is due on the 14th. So yeah, if there are no more questions, then people can leave. If you have anything else, feel free to stay behind. Yeah, Kartik and I will be here for a couple minutes afterwards. So